have a conveyor. I hit right mouse button, we can turn it. So I place it, place it. Let's go up. That's it wants to do, and then clear its own variables. The belt keeps feeding into it. Alright, so let's see how that is all done. This is our conveyor, and he's on a layer. So there's an empty object with a trigger on a layer. Now there's a child, which is literally just a cube, and then I've got the arrow there, and you don't need, I mean, you can use anything you want. These are just models. Like they don't contain any logic. The logic of what this thing is just an empty with a cube that's a collider that's on a layer. That's all this thing is. Now notice the anchor point, right? This little guy here, like if you go like this is our anchor point. I have at the top of the conveyor. It makes things a little easier to do. You don't have to do it that way, but if you don't do it that way, then you have to add offsets. Kind of when you're moving objects, I guess you could say, but you might have to add offsets depending on the box or the ore, whatever you're moving anyways, depending on its anchor point. But when you go to place these things down, you'll have to add an offset going one way. So I put the anchor point at the top. For me, it seems easier, but in reality you could put it at the bottom, because you have to add offsets to something anyways, regardless. It's just a matter of where you add these offsets. So anyways, here is our conveyor. So what we have is we have a conveyor, and we have a canvas, which is actually going to have a proxy list, and I'll give it an FSM. And in this FSM, let's add a state, which is going to have a global event. We'll call it find connections, and in that I am going to send an event to everything in this list, exclude self, to find connections, right? And then in the list itself, I'm going to enable the events. Let's go copy and paste this real quick. Copy. Only on that, because you can't highlight it if you don't. Right, so if we add and if we remove, so if anything gets added or removed from the list, this event's going to fire and this thing will fire. Cool, right? So the conveyor, I'll show you what this looks like. You can call this whatever you want. I'll call it conveyor. So this thing needs to have a next frame event, and let's give that a finish, and then it can get owner. So we're just going to get a reference to ourself, right? So we'll just call it self, or we can call it this, and array list add. Now that means this guy is going to need to be a global, right? So let's also get owner, store him as a global. I'm just going to call one called list. So now everything can find him, right? So back in here, we're going to look at, we want the list object, and we know the reference name is list. We want to add a game object, and we want to add our self. So we've got to make sure to get our self first, and there we have it, right? So just that little piece of logic should have it so that anytime you create a conveyor piece, that it's going to add to this list. In return, because we've enabled the events, anytime anything gets added to the list, this object's going to tell everything in the list to find its connections, right? So we'll I mean, we haven't done that part of the logic, obviously, right? So, but we can see if I go into here, we have find connections has fired off, right? Because this list contains a conveyor. Cool. So in here, let's add another FSM. Let's not put the logic to actually run the FSM or run the conveyor and the find connections in the same FSM. Let's separate those. So find connections. And in here, we're just going to have the same. Doesn't necessarily have to be the same, but we know on that manager it fires off this event. So when it fires off this event to everything, what we want to do is raycast, and we're going to raycast forward and a distance of, say, 1. You don't necessarily have to use 1. I'm going to use 1. Hit hit object. So we have the hit event, hit object. Let's not repeat, and let's add a layer and put this on the belt. Alright, so then we can add a finish. So, and we'll add our hit. So if we hit something, we'll go here. If we don't hit something, we're going to end up going here. Okay, and let's just see how that works. If I just hit play, we'll see now that our canvas has taken in a object, so it has fired off its event because we've added to it. And we look at our conveyor, we look into our find connections, and it got fired off, and it went to the finish because it obviously didn't find another conveyor in front of it. Obviously there's nothing there. Perfect, everything's working. So like I said, we have our two not hit and hit. Alright, now let's get into our actual conveyor. Right, so let's build a new little string here. Now I went to ecosystem, and this kind of makes your life a little easier. Is if you look up multi-condition, it's very picky on the spelling, by the way. Don't add the S, don't put a space. You'll have bool multi-condition, and it just makes life easier. Okay, so this FSM needs some variables. So let's first add some variables. Let's say has item, and then let's do a game object because we need the actual item. And then we also have a connected conveyor. Right, so that's the object that we're going to feed to. Alright, so in here, let's just say bool test, and get FSM bool, and let's is null. Let's bring those in, and then we can bring in our bool multi-condition and bring that in. So the multi-condition will go at the bottom. So is the item null? And we can put this on every frame. So I'm not going to use the events, I'm just going to store the result. Item is null. Right? Get FSM bool. So we're going to look into the conveyor, and we're going to look into has item, and this is going to, we're going to call this one connected conveyor has item, and then I'm going to change this target to our connected conveyor. every frame. And then I'm also going to have has item. Oh wait, no, I don't need that one. I don't need that one. Let's go to, I think there should be 3. Yeah, there is 3. Okay, so we're going to look at the connected object has an item. That needs to be false. And we're going to look at, do we have an item? That needs to be true. And then we're going to say item is null. That needs to be a false statement. And every frame, and if this is true, move item. Right? And if we're going to move the item, so we've determined that this chunk of conveyor has an item on it. Okay, and we know the next chunk of the conveyor does not have an item, so it is safe to say that we can move our item to the chunk. Right, so we need to get position of our connected conveyor, connected conveyor. Oh my god, my spelling. Whatever. Let's add, so let's vector 3 add XYZ. So this is where we can add our offset if needed. Right, so let's add a variable here called offset. Alright, now let's stick that guy in the inspector so we can see it from out there. But I'm going to leave it 0 for now. I don't know if we actually need the offset, but the option's now there. Right, so we are now going to set FSM bool, and we're going to set in the conveyor has item to true, and this is actually going to be in our connected conveyor. So we're going to tell the other conveyor, hey, you have an item. He doesn't actually have an item yet, but he has an item by the bool. We're not giving him the item yet, but he has it by the bool. Right? So the value is true. Then we want to move towards, and there's different ways you could do this movement too, but we'll use the move towards. And we're going to move our item to the connected conveyor position. Right? We could use the target object, but this position will give us the ability to do that offset if needed. Let's give it a speed of, like, say 2 and a finish distance of 0.001. And then we can give that a finished. Right? So once we're moving our object, we can come down here. So we've moved our object. Our object is now at the other conveyor. We need to do a few things. We need to set FSM game object, and we need to set, okay, let's keep that on for now, into the conveyor, set the item to item, but this isn't ourselves, this is on the connected conveyor, so we are giving our item to them. And now that we've given it to them, we need to make sure we set our item after we've given it to them to null. We're just going to leave that one blank. And then we can now set bool. So we'll set our has item to false. And then we can just move back up here. That little trivector of states is all the movement you need for this conveyor. Now, that's if there's a connecting conveyor. So what if there isn't a connecting conveyor? So let's copy this and stick it here. Now, there's a difference, because over here, do we have an item? Item is null. Right? Now, you're going to think, now this is if we're at the end. We're the end conveyor. So we don't have a connected conveyor. So we'll get rid of that. So we need to bring that down. Right? So we're looking at item is null, that needs to be a false statement. Has item, that needs to be a true statement, right? Because we don't care about the connected conveyor because we don't have one. And if that's the case, now we can move item. Now, we can't get position of an item we don't have because we don't have a connected conveyor. So what do? Well, I'm going to remove that, and instead we're going to transform point of ourselves, and we'll give this a distance, right? I can go 2, 1. I'm going to go about 0.75, and I'm going to tell that that's the connected conveyor's position, right? Even though it's technically a position of ourselves with an offset. So the offset can stay the same. There is no bool to set, so we move our item there. Now once we have achieved that, we are not setting a game object to anything, but we are clearing ours, and then we're going back here. So the other difference is once we're here, let's tell our item, so this needs to be before we null it, our item, that it's no longer kinetic. And then just for shits and giggles, let's add some force. Right, so we can add force, and let's put it below the kinetic but above the null. Right, so there's our item, force, and let's vector 3 multiply. So let's take the transform direction. So let's get a direction. Let's get our direction of our forward. And let's multiply our forward by some value, like, I don't know, say 50. And then we can now apply on a vector our forward to the item. And that'll just give it that little push off the conveyor. 50 force isn't that much, right? Obviously that would change if you put a weight to your box too. So here's our two movements, right? We have non-connected and connected movements. So let's go like this. Let's just go connected movement. Oh, that made it ugly. And non-connected movement. Now we can get over here. So if we find connections, so if we don't have a connection, we could tell the other FSM, like, hey, you don't have a connection, use the other path. The thing is, if we're in this guy and we're in one of these states, we're already moving items. We've already changed bools. We're changing items. And if we also swap over here, we're going to screw up some references, and we don't want that, right? So let's make sure that we are in one of these two states. It doesn't matter which one, but one of these two states. So if we go, well, like, we don't have much of a state here, so let's just add a new bool, and this will be kind of more of a local bool, I guess. And let's say it's can change. We'll say that, right? And then let's just set bool. Put this right at the top. So can change is true. Copy that and stick it over in this one. Before that, can change is true. And then let's stick in the top of these two first states as false. Right, so if we're over here, it's true. Once we hit over here, it's false. So if we're over here, all we're going to do is get FSM bool and bool test. We're going to get our own from the conveyor, can change, and we can put this down as can change every frame, and if this is true, we're going to say you send event. Send event to ourselves, to the conveyor, and this is the non-connected movement, right? So if we copy this, actually, let's just go like this, place it here, and this can be under the hit, right? So this will be can change. So this will be the same, that doesn't change, and this is going to be now the connected movement. The other difference is if we have an object from here, we can also set FSM game object to the conveyor. The connected conveyor is now our hit object, and we might, just for reinsurance, place that up in here as well, but set this to null, just in case maybe we've destroyed a conveyor or something. We want to make sure that connection's gone. Right, so there, now we have these objects. So let's see. Let's go like this. Has item. I'm going to stick this out in the input and the item out in the input. Right, so we can see this for a minute. Now if I just duplicate this, push them out, alright, and I can even turn it. Like that. Now if I hit play, we should have a whole whack of these things should all enter the list, right? And they should all find their connections. So let's check the list first. So here's a list. We have all our conveyor chunks. Good. They are there. So let's check. So this guy here should have a connection, right? And he hit, so he has a connection. Now can change is default of false, so we need to just fix that up. You know what, the easy way is going to do this. So can change, the default value needs to be true. And technically it doesn't matter what order you put these in, because they're found by the raycast, right? And if you're off a bit, or if these are tilted a bit, it's not going to really affect anything, right? Like I could, I could put it on angles like this, or I could elevate it so it's going upwards a bit too, right? I can show you that. Right, so there's our kind of little conveyor. It's all screwy now. So if we hit play, kind of like nothing happens, obviously. And if we go into this guy, we're going to see he is now sitting. He has connected movement. He is waiting. So let's take our little object here, and I got this. It's literally just a cube with a rigid body set as kinetic. Let's just stick it on this guy. And then go to the conveyor and say, here is your item, and you have an item. And as you see, he is now trucking along, going upwards. Now, see, and then there he goes, he falls. Now you notice how he was sitting on the inside, right? And that's because this anchor point to this anchor point, that distance, right? So if I, for example, give this a value of, we'll say 0.3, 0.3, and you would kind of do this to them all. Or you would put this guy's anchor point at its bottom. If his anchor point was at the bottom, his anchor point's at the top, then you really don't got to worry about that offset at all. You still put an offset on these things when you create them. So again, like let's take this ore, let's stick them over here, place them nice neatly, say oh, there you go, and go. See, now he's sitting more on top of it, right? Except for, and I didn't do all of the offsets, so but it works, right? So there's that. Now if I delete those, bloop, I'll show you real quick what I did up here. Let's do another FSM, and let's do a button click event. So if we click this button here, create conveyor. So we go and create our conveyor. What are we going to do? We are going to mouse pick. Right, and you might want to throw other events here as well, checking stuff. So let's make sure. Okay, I'm going to put the ground I got on a layer called button. Don't ask me why it's called button. And let's do a layer mask and shoot only for this thing. We're not looking for anything else. We just want to know where the ground is every frame. So that's our hit point. Now we could fire another mouse pick right next to this one and be looking for conveyors, or doing an overlap sphere or a box cast or something at our hit point, looking for other conveyors or whatever the case is, so we don't overlap these things, right? But whatever, right now we're just going to do this. So we found our hit point. Now let's snap, just to make this a little simpler. Let's snap the hit point every frame to that. Let's create, and actually, you know what, we should do that up here. Yes, we should. Right, we're gonna want to, well, you know what, yeah, okay, 1 second, let's move this down. So we're gonna want to create a prefab. I don't have a prefab of it. I suppose I could make one. Right, of our conveyor. Right, so I can delete this one. So we're going to create that, get rid of those, and it's going to be at hit point. Right, and this is going to be created conveyor. Now, so these aren't, I'm going to set these to not every frame. I'm actually going to delete this guy, copy this whole state and bring it down here, and you'll see why in a second. So this guy's just going to finish and come down here, right? So in this first state we do the mouse pick, the snap, and the create. Oh, and then we also want to set position. So we want to set position of the created conveyor world space to the hit point. Now this isn't every frame because this is just a zipping in. But over here, I might as well copy that action. We want that same thing, but these are every frames. But we're not creating it every frame. So you wonder why do that in two states. So what we're going to do is I'm going to grab a mouse button down. Right, and we can do left. That'll be called place, and let's do another one, right, and that'll be called turn. Alright, so now we have place and turn. So if we turn it, let's get rotation. This is just a very simple way to turn this object. The created conveyor, we're going to get the Y. We're going to add to the Y, we're going to add 90. You can do 45s if you want. You can, well, a bunch of different ways you can do this. And then let's set rotation. Move that to the bottom. So the rotation of the created conveyor to the Y, finish and go back here. Which is why we do the create up here, so that we're going in and out of the state. We're not recreating everything over and over and over again. So if we place it, we're going to do something, and then we're going to come back over here. So one thing we should probably do, let's go into our conveyor real quick. So we have this guy, right? The add. I'm actually going to change that. And let's say, let's give it an event called set. Which I guess doesn't need to have a next frame event. And what that'll do is that means in the placement, when we place it, we're going to send an event to, I'm just going to target this prefab real quick, to the conveyor to set. And now I'm going to change this back to the created conveyor reference. Right, so he has now set his place. And the rotate, and there we go. Okay. So let's hit play. Alright, so we hit conveyor, we have a conveyor. I hit right mouse button, we can turn it. So I place it, and I'll place it. Let's go up. Down. You know what? Let's cause a loop. There we go. So I'm just going to duplicate this guy real quick so we can see something. So if I go to the first conveyor, which is this guy over here, and I say, hey you, actually let's take all these ores first. Let's bring them over here. Make this our little starting point. Now obviously you wouldn't be doing this, you would have something else feeding into this. Oh, did I put the offset? Oh, I do have the offsets. Okay, good. Alright, so we go to this first conveyor and I say take this ore, and yes, you have an item, go. As you see, he's just going to start marching along, and I can, but he's empty now, right? So I can say take this ore, and yes, you have an item. Alright, now let's say you can take this item. Oh, Jesus, I messed that one up. I messed that one up because he's obviously taken. That guy's taken. Oh my God. Why would I do that? Why? Right, let's fix that. So he's missing. There we go. Okay, don't reuse the ore that's already out there. It's obviously not a good thing. Alright, so we have two. So let's put this guy. Alright, and then let's go 4. And then let's go 5. 6. 7. Oh, did I copy it again? Did I do something? I shouldn't have done something. 7. Oh, I did. I totally did. Man. Yeah, obviously you wouldn't be doing that. That would be a bad thing. Doing this by hand like that. Alright, so we know we have, so I can do 8. Let's go down and grab 8. And if we wanted to, we could also do 9. Now, as you see, they don't overlap. There's something, I probably have a screwed up variable over here or something. But yeah, I mean, typically they just kind of work right now. Obviously, you wouldn't be forcing these variables in like that. I mean, that's obviously a great way to break things, as you can tell. But in itself, it works, right? And I don't have a way to delete things, but let's go. You see, now I've added things and everything's still working, of course, other than that one screwed up one, which we're not going to worry about. And if we look at the new conveyor, this guy, let's add a new ore here. So let's grab an ore that we know isn't being used, because that just breaks everything. And grab this guy and say, you take this ore and you are now part of the system. Alright. And that's because those conveyors have that one final connection that's actually looking to see if they're able to add into this new connection or not. Let's get rid of that. Number 5. He was problematic. Right? But yeah, so there is a nice little conveyor system that you can use, right? And the beauty part is these little guys, if you have like say a machine, like a mining machine, like I built one earlier, testing phase, and it was say sitting here, all it has to do is create the ore, the item, whatever it is going to be going across the conveyor, place it on top of this thing with position and set position, and then it just needs to give it the item and tell it true, and then poof, off it goes, right? It just works, right? Vice versa, these things have that connected, non-connected, so they don't really care. As long as they have connected movement, they're going to move something in there and then give the item there. So if this will say like a processing plant, like a smelter, we'll say, that logic still runs fine. It would go into the smelter, it would settle the stuff, and it would more or less tell the smelter, okay, here's your item, and you have an item is true. Now the smelter could do whatever process it wants to do and then clear its own variables. The belt keeps feeding into it. And you have this automated process also happening of mining coming in, mining going out, or smeltering, or whatever the conveyors are used for. Who knows, right? And like I said, like these conveyors can also be added onto or destroyed in real time, right? Like if I destroyed this guy, now if I just deleted him, that's not going to work. That's just going to cause null issues. So the conveyor would have to have some sort of, if you destroy it, you could have it on disable, so disable and then destroy, or if you're going to destroy something, you would destroy the item after you removed it from the list, right? So you choose this conveyor, so you take that conveyor, you remove it from this list with get the conveyor array list removed, and then once it's removed, then destroy that item. And then once that happens, because the way the logic's set up, this thing would do its find connections, and you could always tell this thing to find connections anyways. You can just send an event, find connections, right? You can destroy it and tell, hey, go. And then it would just recalculate. So this guy would become a non-connected movement. So he would just be dumping his blocks all on the ground all of a sudden, right? But you could place a new tile there, and maybe now you're going this way, going down. It would reconnect and off it would go. So there you have it, conveyor systems.